All right, in this section, we are looking at solving systems that have a quadratic and a linear system. So there's a few different ways to solve these types of systems. And just like in solving linear systems, we can solve by graphing as one of our ways. So what we want to do here is we need to graph both equations. So x squared minus 2x minus 1 and minus 2x minus 1 in order to see where they intersect and find out and check and see if that point is a solution. Now, you guys already know how to graph both a quadratic and a linear, so we're not going to spend this whole time reteaching how to do that. But I want to look at a couple characteristics that you can see from these graphs just to give you an idea of what things you can be looking for. So right now you can look to see how these graphs, what characteristics they have. Now for our linear graph right here, you see that here we've got a slope of -2 and a y-intercept of -1. So that does tell you some information that'll help you graph this. So at our y-intercept of -1 on the y-axis, we have a slope of -2. So remember, this will be going over 1, down 2. On our quadratic right here, what you can look for is if you go ahead and take the discriminant of this, so b squared minus 4ac, you'll see right here that b squared is 4, and you'll be doing minus 4 times 1 times -1. So you'll be doing 4 minus 4. So this only has one root right here. So because our discriminant is equal to 0, it only has one root. Now, when you go ahead and factor this, you're going to end up getting x minus 1 squared. So your root is going to be at x equals 1. So that tells you right here that your vertex and your one root are the same. So you're going to be at x equals 1 for your vertex. Now that gives you an idea of where to start graphing at for this. So again, just some hints that you can look at when graphing this. Now we can see, I'm going to pull up Desmos real quick. When we look at this graph right here, this right here is our parabola, x squared minus 2x minus 1, and our linear is minus 2x minus 1. What you'll see is that your graph right here appears to cross at 0, -1. So that point at which they cross is going to be your solution to these systems. So again, remember, x equals 0 and y equals -1. So if we come back here and we go through, you'll see, again, this graph shows a little version of what we just saw in Desmos. Our point of intersection appears to be 0, -1, and we can check this point by substituting these coordinates into each of the original equations. Now for our first right here, if we go ahead and plug 0 for x into our first one and -1 for y, we end up with -1 equals 0 squared minus 2 times 0 minus 1. So we end up with -1 equals -1, which is a true statement. So right now our point works for our quadratic equation. Now we're going to do the same thing for our linear equation. So y equals -2x minus 1. We take our point, 0, -1, we plug it in here. So we get -1 for y, 0 for x. So we get -1 times or equals -1. We can see that -2 times 0 is 0. So -1 equals -1. So right there, because our point gives us true statements for each of our equation, that shows us that it is indeed our solution. And again, graphically, that's our point in which both of our graphs touched and met.